Hey guys, I purchased this Weston model number 633 clip-on ammeter. It's a vintage one. It's in decent condition cosmetically based on what it's selling at on eBay and other places. I didn't pay much. And the weight of this, for those interested in knowing, is 1,780 grams. I'm testing with an iron box because immediately the only thing I could think of for a decent load was an iron box. This is 100 amperes. Okay, turns on. It's a full scale. I hope you can see. So it goes full scale. Naturally on 25 also it goes full scale. I think it is the same multiplier. Shunt rather, not multiplier. Sorry. Same. Resistance measurement. .25 ampere range, 100 ampere range, 250 ampere range, 500 ampere range, 1000 ampere range. This is the first one. When it is in 10 ampere mode, this should be the resistance, total resistance measured. Now I have isolated this port. So this is across the meter. 9.43 kilo ohm, 25 amperes. This resistor or coil comes into picture. This is 1.758 kilo ohms. 0.881 kilo ohm in 100 ampere position. And it is 12.27 kilo ohms. 12.2728. That is the value of this one. This is in 250 ampere scale position. This is only 54.3 ohms and this is 27.6 ohms and this one 26.1 ohm. So we need to figure why the difference, plus we need to figure why the value of this is so high compared to all the rest. Okay, I did suspect this, the coil here or the resistor, resistance, coil, whatever, I suspected that one because that was the one when we moved to that position that had the highest, that means 250 ampere scale, that means 10, 25, 100 and 250 range. 250 range, the connection was through this coil that showed the highest resistance. Rest are all low. These are all pretty low. These are marginal. This was very high and over 10 kilo ohm. So I suspected that, so I removed it. Initially I thought of desoldering. I switched on the desoldering station. I don't need. Then I removed this screw, removed the terminal. It's here. So the terminal, this terminal was here. I removed it, screwed it back. And this one, the screw was this one. This screw was holding from the top. From the top this way onto this one. I removed it and then isolated this terminal. And now the readings are similar. I'll measure from here. One terminal, so it is going here, and the other one is this one. So when I measure, it is open. I was not able to use the same wire that was on this bobbin. One extremely thin wire, and it was cut on the inside. That means where it started the turns, that point was cut and there was no point in winding it back. So now what I did is I could not even measure because it is so thin, thinner than the hair, multi-strand, and even removing the enamel from that was difficult and I could not measure. So based on the values of the resistance, DC resistance, I'm sure with the slug, the steel screw as the slug, I'm sure there will be some inductive reactance. Anyway, now I'm taking the easy path out. Based on the DC resistance of the first coil and the second coil and the remaining coils, I just came up with a value 330 ohms for this one. And then I have actually soldered a quarter watt resistor. If you can see it, it's a quarter watt resistor. Now based on that, so now if I do a DC measurement, this is in the 10 ampere range. So 10 amperes, you can see the reading, it's 2.071 kilo ohm, 2.70. It's totally different from what it was, and this is how typically it should be. So now this is the 25 ampere range. This is 100 ampere range, 250 ampere range, 500 ampere range, 1000 ampere range. Now I change it to 150 ohm resistor. This is with the 150 ohm resistor. 10 ampere range, 25 ampere range, 100 ampere range, 250 ampere range, 500 ampere range, 1000 ampere range.
Guys, here is a rough schematic. And based on the rough schematic, here is the simplified diagram, which should explain how the connections are made. So on the top, we have the load, the meter itself. The values may differ now, but hopefully one of these days I should be able to, if anybody is interested, I can provide the actual readings. After the missing resistor, the third resistor from the left, that value was unknown. That's the one that was defective, which was open. I have now replaced that with a 150 ohm resistor. So the total resistance when measured naturally will not be 9.44 kilo ohm now.
Okay, I'll now be doing some actual tests with the mains connected. I have connected the mains here, and it is going through a loop here, the phase wire, and here I have plugged in a space heater. This is what I could immediately find with the switchable loads. There are two separate heaters here, so that way I can make the load almost half and then double that. I'll start off with the 10 ampere range. So this should give about 7 amperes. Yeah, this is giving 7 amperes. One of the heaters is on. And since it's a 10 ampere range, if I switch on the other heater, it will go beyond the scale. So I'll switch this off. I'll switch on the other heater. This should give about 6 amperes. So that's a total of 13 amperes. So when I move to 25 ampere range, I'll switch on both. That should give about 13 amperes. So it is in the 25 ampere range scale. So it is 5, 10 and 15. So 10 and 12.5, about 13 amperes. They are very close to 13 amperes. A little less it is showing. So that's the in the 25 ampere range. But if I move to the 100 ampere range, it should technically show just a little over the first division, because the 10 ampere range, 8, 9, 10. So it should go with all the other resistor values which I tried. It was showing a little higher. So now by experiment, by trying out different values, now with this value 150 ohm resistor in that position, the 100 ampere switch position, it is just showing a little over the first division. I'll switch it to 100 ampere. Yeah, now this is pretty accurate for my kind of work, because I don't think I'll be using the 100 ampere range much, but nevertheless it is still very close to, considering the vintage of this meter. I think this accuracy is good enough for me. So earlier it was very high, now it is just a little over 10 amperes, and this is 20 ampere. So it's just around 13, 14 maybe amperes it is showing, which is pretty good. And this is again in the 25 ampere range. So guys, that concludes the repair of this Weston model number 633 clip-on ammeter. Thank you for your time.